Hello, welcome to Math with Mr. Dobrescu to the rescue. Today we are learning about relations and functions. Think about functions as vending machines, right? Many of us have been using vending machines in the past, or even now we are using a vending machine. So you go to the vending machine, you have $1 in your hand, and you want to get a bottle of water. So you put on the dollar into the spot where it takes your money, right? So the dollar is your input. And then you expect to get only one bottle of water. So the bottle of water is the output. Please remember that with functions, for each input, there should be exactly one output, not two outputs. One output, right? You don't put $1 and then expect to get 2 bottles of water, right? Or you put $1 and you want to get a bottle of water, you're not gonna get a Pepsi or orange juice, right? You are going to get the bottle of water, okay? So remember that for each input, the dollar, there is exactly one output. Very important when we solve functions and when we identify functions. Let's take a look at this example here. We have a shape here, and this is a rectangle, and then we have the area. The input is x, and they are giving us some value. We have some values for the input. We have 1, 2, 3, and 4, and then the output is the area, the A, right? So to solve this problem, to find the output for our inputs, we need to use the formula for the rectangle, right? So the area of a rectangle equals, if you remember, length times the width. So L times W, okay? And now if we put that information into our function, into that machine here, into our rectangle, right? So this is our function. See if we can get the output. So first of all, we start with the formula. So area equals the length. Our length is the x, right? So x is our length, okay? Don't forget that. So the first input for x is 1. So we are going to input 1 for L, and then W is 2. So we have 1 times 2. And 1 times 2 is 2. So the output is 2. And the order pair is 1, 2. 1, 2. This is our first. The input is x and the output is 2. After we put 1 into the formula, we get 2 as the output. Let's continue. Let's put 2 now. So instead of x, we are going to put 2. So we have area equals, instead of L, we are going to put 2. 2 times 2, which is 4. So our output is 4 when we input 2. 2, 4. Now let's continue the pattern. So now we have the area equals, instead of x, we are going to put 3. 3 times 2, which is 6. And the order pair is 3, 6. And finally, the area equals, instead of x, we are going to put 4. Length times width, which is 2. And 4 times 2 equals 8. So we have 4 and 8. So if we look at the pattern here, for the input increased each time by 1, right? So we added 1 each time, plus 1, plus 1, plus 1, right? Now the output, we added 2 each time. That's the pattern. So here, plus 2, plus 2, plus 2. That's the pattern. Okay? Let's continue with our next example. We still have the rectangle here, right? But now they are giving us the perimeter for the output. Perimeter, right? So now we are going to use the formula for the perimeter. So the perimeter of the rectangle is what? We have two lengths that are the same, or we can say 2L, and then we need to add the width, and we have two of them that are the same, plus 2W. This is the formula for the perimeter. And now we need to identify X, if X is either L or W. And of course, X is the longer side, which is the L, right? So our X is the L. And let's plug it in now. So the perimeter equals, we are going to plug in first 1 for X, and then 2 for X, and so forth, right? So we have 2 times, instead of L or the X, we are going to put 1. 2 times 1 plus 2 times W, which is 2. And let's see what we get. 2 times 1 is 2. 2 times 2 is 4. 4 plus 2 is 6. So the output in this case is 6. And the order pair is 1, 6. And let's continue the pattern. So now we have again the perimeter equals, instead of X, now we are going to put 2. So we have 2 times, instead of L, we put 2. 2 times 2 plus, the second part stays the same, 2 times 2. 2 times 2 is 4. 2 times 2 is 4. 4 plus 4 is 8. So the output is 8 when we input 2. So we have 2, 8. And let's continue. Now we have P equals, instead of L, we are going to put 3 for the X. So we have 2 times 3 plus 2 times 2. 2 times 3 is 6. And then 2 times 2 is 4. And 6 plus 4 is 10. So here we have 10. And the order pair is 3, 10. And finally, we have P equals, instead of X or L, we put 4. So we have 2 times 4 plus 2 times 2. 2 times 4 is 8. 2 times 2 is 4. 8 plus 4 is 12. So the output is 12. 4, 12. And again, if we look at the pattern here, we see that again the input stays the same, so it increases by 1. So we are adding 1 each time. And the output increases again by 2. We're adding 2 each time. From 6 to get to 8, we add 2. From 8 to get to 10, we add 2. And from 10 to get to 12, we add 2. So this is the pattern. Okay? Let's look at another example. Now, tell me about this shape. So here we see a what? Here we see a circle, right? And they are giving us the circumference for the output. So we are going to always start with the formula. The circumference of a circle is, if you remember, 2 pi r, right? 2 times pi times r. Okay? And now we are going to put each time, for the r we put 1, and then we input 2, 3, and 4. So we have C equals 2 times pi, and instead of r, we are going to put 1 first, times 1. 2 times 1 is 2, so we get 2 pi. So the output is 2 pi. So here we have 1, 2 pi. If you want to get a number instead of the pi, remember pi equals 3.14. So if you want to get a number, you can substitute 3.14 for pi, and you multiply 2 times 3.14, and then you get a number instead of getting the pi there. But let's leave the answer in terms of pi. Okay, let's continue. C equals 2 times pi. And now we are going to put 2 for r, right? Times 2. And then 2 times 2 is 4. And here we get 4 pi. So the ordered pair is 2 and 4 pi. And let's continue. Let's continue now with, instead of r, we put 3. So we have circumference equals 2 times pi times 3. 2 times 3 is 6. So we get 6 pi. So we have 3, comma, 6 pi. And finally, we are going to put 4 for r. So we have c equals 2 times pi times 4. 2 times 4 is 8. So we get 8 pi. So the ordered pair is 4 and 8 pi. And again, the pattern is the input increased by 1. So this stays the same. We add 1 each time for the input, and the output, again, the same, from 2 to 4, plus 2 each time, right? So plus 2 each time. Okay? And of course, all of these are functions, because for each input, there is exactly one output. Each input, exactly one output. For all of these inputs, we get exactly one output. And finally, let's take a look at this example here. So here we have a volume in this shape. If you remember, many of you may say a cube, right? But it doesn't look exactly like a cube because it's a little bit longer, right? So this is called a rectangular prism, right? Okay, so the volume of this shape equals, if you remember, the volume formula is area of the base, or the big B. We call the big B the area of the base times the height, right? Times the height. And in our case, the base is a square, so the area of the base is 3 times 3, right? 3 times 3, and then we have to multiply times height. Okay? So again, each time we are going to input all the values here for the h. So first we are going to put 1 for h. Next we are going to put 2 for h and see what we get. And then we are going to input 3 for h, and finally 4 for h and see what we get. So let's use the formula. So we have v equals 3 times 3, right? 3 times 3. And the first value is going to be 1 for h. So let's substitute h with 1. And here we get 3 times 3 times 1, we get 9. So the output is 9. So we have 1, comma 9. And let's continue. So we have v equals, and then now let's substitute 2 for h. So we have 3 times 3 times 2 now. And we know that 3 times 3 is 9. 9 times 2 is 18. So the output is 18 for 2. So we have 2, comma 18. And let's continue. So we have v equals 3 times 3 times, now instead of h we put 3. And 3 times 3 times 3, we get 27, right? So 27. So the order pair is 3, 27. And finally, instead of h we put 4, so we have 3 times 3 times 4, which is 3 times 3 is 9 times 4, 36. So the order pair is 4, comma 36. Oops. 36. Okay? So again, the input, we added 1 each time, right? So plus 1 each time. This never changed because we use the same numbers for the input. But here we see that each time from 9 to get to 18, we added 9. From 18 to get to 27, we added 9. And from 27 to get to 36, we added 9. So the pattern here, we added 9 each time. And again, for each input, there is exactly one output. So we call this a function, right? Each input, exactly one output. Again, please remember to practice, and remember, anytime you work and you try to identify if a relation is a function, please remember the example Mr. Dobrescu gave you today. The vending machine, right? When you put $1 there in the vending machine, for each input, you get exactly one output, right? If you want to get a bottle of water, you get a bottle of water. So you put $1, it's the input, and you get the bottle of water. Not Pepsi, not orange, not anything else, but the one bottle of water, only one. Again, each input, there is exactly one output. Thank you all so much for watching. Again, I appreciate it. And please don't forget to like and subscribe and share these videos with your friends and family members so everyone is going to be proficient in identifying functions. All the best. Take care.